Here's the lesson 2 activity for college algebra. First, we're going to talk about union and intersection of sets. So the members of the 1961 rock band, the Beatles, and the members that arrived in 1964 in the US were not the same band. So we're going to let A be the members from 61 and B be the members from the 64 group. And we use the roster method to list them. Now we're going to imagine that all the members listed above are still alive, and we were going to plan a reunion. So the members who would come to the reunion would be everyone. So the union of two sets is just put everything into one big set. So this would be John, Paul, George, Stuart, Pete, and Ringo. That's everyone that was either in the first version or the second version of the Beatles. So the set of reunion members is called the union of the sets A and B, and we denote it with this big capital U. Sometimes we read it A or B. So based on the reunion example, explain in your own words how you form the union of two sets. So it's like you marry them together. Now we're going to let D represent the set made up of members that were common to both bands. So who is in both the original and the new version? So that would be John, Paul, and George. So this is the intersection of sets A and B. We denote intersection with this like upside down U. Sometimes we read it A and B. Who is in both A and B? So it is the overlap. I think of it as the overlap of the two sets. So let's do some intersections and unions with sets of numbers. So I want to graph the interval 1 to 4 on a number line. So 1 would be the smallest. It's not included because it's got a round bracket. And 4 is the biggest. So there's that interval. And then 2 to 8, including the 2 and including the 8. So using interval notation, I want to find the intersection or the overlap of these two sets. So 2 is in the second set, but it's not in the first. So it's not it is. 2 is in the first set. Yeah, I was looking at the 1. So 2 is in both sets. So I think 2 is definitely in the intersection. So I'm going to include it. Okay, and then where else do they overlap? They overlap from here to here. They have that space in common. So it looks like they go up until 4, they have numbers in common. 4 is in the second set, but it's not in the first set, so I can't include it in the intersection. It would have to be in both to be in the intersection. Okay, our next topic is absolute value. The following is an algebraic definition of the absolute value. So the absolute value of x, it says that it's equal to x when x is positive. Like if x is bigger than or equal to 0, the absolute value of x is just itself. And then it says the absolute value of x is negative x if x is already negative. So this says if x is already negative, you put another negative sign in front of it, and that would make it positive. So that can be confusing because it looks like the absolute value is sometimes negative. But the absolute value of a number is always positive. This negative sign means put that negative sign in front of an already negative number to make it positive. Okay, so let's answer always, sometimes, or never for the following sets. So we have a statement. We want to say, is it always, sometimes, or never true? And then we'll either change it to make it true, or we'll show a counterexample. So negative absolute value of x is negative. This is almost always true, right? Almost always, because the absolute value of a number is always going to be positive, or 0. That's the little exception there. And then if you put a negative sign in front of a positive number, it's going to be negative. So this is almost always true. So I have to say sometimes, because it's not always true. The only exception is negative absolute value of 0 is negative 0, which is 0, right? So, and 0 is neither positive nor negative. So this is my exception. Otherwise, it's always true. Now, if I take a negative sign and put it in front of the x, whether x is positive or negative, so what's inside these absolute value bars could be positive, could be negative. But when I take the absolute value, it's going to be positive. So this is never true. Right? The absolute value of negative x is always going to be bigger than or equal to 0. All right, the difference a minus b and b minus a, if I look at each one in absolute value, are they always the same? We'll do a couple examples in your head just to check. So let's see, I'll write it over here, like 3 minus 5 versus 5 minus 3. One is 2 and one is negative 2, and if I put them in absolute value, they both come out to 2. And that is always going to happen. This is always true. And the square root of x squared is always the absolute value of x. Well, let's try both a positive and a negative value for x. So if I do the square root of 4 squared, that's the square root of 16, which is 4. Okay, so that was x equals 4. And it turned out that that was true. The absolute value of 4 is 4. So I could say, yeah, that is the absolute value of 4. Okay. What happens if I do this with negative 4? This is the square root of negative 4 squared. That's the square root of 16, which is positive 4. That is the absolute value of the number I started with, negative 4. So, yeah, this is always true. Recall the model from the demo that showed tuition and fees T based on the number of academic years since 1985-1986. So on average, by how many dollars per year was tuition increasing from 85-86 to 2015-2016? So this quantity is called the average rate of change for the model. And to calculate average rate of change, we just look at the total change, like what is the change in tuition from 1985 to 2015, and then we divide by the number of years. So you break it into 30 equal amounts. So that tells us the average rate of change. So the tuition in 2015, I'm just going to plug a 30 into the model, and you get 9,909.3. And then in 85, that's year 0. If I put a 0 into the model, I get 298585. And then I'm going to divide that over the course of 30 years, and we'll see how much per year. 9909.3 minus 2985.85 divided by 30, and you get $230.78. $230.78 per year. That's about the average increase in price each year. Okay, so after you have reviewed and taken notes on section P1 in your textbook, we should be able to answer these questions. So we want to list all of the numbers in the following set. So I've got 5 numbers there. And I want to identify them as natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So natural numbers, those are considered the counting numbers starting at 1. So 1, 2, 3, etc. So are any of these natural counting numbers? And the answer is yes, the square root of 49, because that's just 7. Right? Or 7. That is a counting number. 0 is not considered a natural number, but it is considered a whole number. So any whole numbers would be 0, 1, 2, 3, 4, etc. So it's all the natural numbers plus 0. So whole numbers would be 0 and square root 49. Integers are positive and negative whole numbers. So that would be the negative 7, the 0, and the square root of 49. Rational numbers are any number that can be written as a fraction where the top and bottom are integers and the bottom's not 0. So any integer is a rational number because you can always write it as over 1. And so I'm going to have the negative 7. 0.6, that can be written as 6 over 10, so that is also rational. Negative 0.6. 49, that can be written as 7 over 1, so the square root of 49 is also rational. Square root of 50 is not, so I cannot write that as a fraction. So it is going in the list of irrational numbers. And finally, the real numbers, which is all of them. So it would just be negative 7, negative 0.6, 0, radical 49, and radical 50. All right, last question. Determine whether each statement is true or false. If the statement is false, make the necessary changes to produce a true statement. Every integer is a rational number. True. Every integer can be written as over 1, making it rational. The term x has no coefficient. This is false. X is the same thing as 1x. So it does have a coefficient of 1. So x has a coefficient of 1. Okay, 5 plus 3 times x minus 4 is 8 times x minus 4, which is 8x minus 32. So they added this 5 plus 3 to get the 8, which is not a legal move because you have to do multiplication before addition, and this is 3 times what's in the parentheses. So you can't do that addition until you've multiplied the 3 times the x minus 4, and the way you do that is to distribute. So this one's false, and we'll fix it by doing 5 plus 3 times x minus 4, which is 5 plus 3x minus 12, which is 3x minus 7. And then x squared plus 36 does not equal x plus 6 squared, because look what happens if you multiply x plus 6 squared. X plus 6 squared. That is x plus 6 times x plus 6, which is x squared plus 6x plus 6x plus 36, or x squared plus 12x plus 36, which is not x plus 6, which is not x squared plus 36. Right, there's a 12x in there.